Hi, welcome. In this episode, we're going to talk about geographic maps. In particular, we're going to look at how we can use some different types of mapping in cartopy, which is a platform in Python for mapping. So here's one example of the types of projection that we were talking about earlier. This is the orthographic projection of the globe. So we're going to use Pandas and matplotlib as usual. We're going to import cartopy CRS, which is a coordinate reference system, as CCRS, and then we're going to be able to define a map projection. And you remember that the map projection goes from the globe to a 2D page. And here, orthographic just projects the globe almost directly as it is. If you imagine parallel lines of light coming out from the globe, it just projects it as a circle onto the page. And you do need to provide a central latitude and longitude. Is a point here on the UK, which is almost exactly over Newcastle. We're going to draw it with a plot. And the figure size is 8 by 6 inches at the standard DPI. We set the axes as 111, so there's only one plot. I'm going to address the first of those one plots. The projection here is the important part. This is taking the globe, the WGS84 standard reference globe that Python uses, and applying this projection to it to create the image you see. We're adding grid lines and coastlines so you can see something on the world as well. So there you go. That's the orthographic projection of the world using cartopy. Now this is the Mercator projection. You will remember that this is the standard web projection of the world onto a map. And this is taking most of the globe into a projection on a 2D plane. And I've labelled here the different lines of latitude and longitude in degrees, 30-degree separations. And you'll see that equal steps across in lines of longitude are equal distances, whereas equal steps down or up in the lines of latitude are not equal distances on the map. But the Mercator projection, as you might remember, it preserves the shape of an object on the surface of the Earth. It doesn't preserve its size, it preserves shape. A key thing in the Mercator projection is the latitude and longitude. And in particular, we're going to set a minimum and maximum latitude, because if you go beyond this, the map goes out to infinity, and in fact you get very little useful information beyond about 85 degrees north and south of the equator. Let's swap to look at the Python here. We're going to just put in Mercator as a projection, and we'll let it choose the standard range from north to south on there, and we'll run that and we'll see what happens. So here's the result. There's that plot we just saw. It's cut off, I think, at about 83 degrees, so slightly closer to the equator than the one I just showed you. This little tip of Russia here wraps around to the other side, and there's the strait there between Alaska and Russia. So you can also use a projection of plate carré. So you might remember that plate carré has this nice property that you can plot directly on here in degrees, longitude and degrees latitude. And remember that equal amounts of distance on the 2D plane are equal numbers of degrees. So this is a 30 degree here from 60 to 90. This here, halfway across here, that will also be 30 degrees from 180 to 150. So you get a square in degrees. And we'll see in a second that it's widely used by NASA in plotting their blue marble images and other downloadable images from the NASA sites around the world. So this is the plate carré and the Mercator projection side by side, so you can see the difference. Remember, the Mercator is on the right. It is the standard mapping that the web uses. And on the left, plate carré is the standard mapping that GIS systems tend to use. Both of these offer different distortions of shape and different benefits. This one is one that projects true size of area of features across the globe. So you could compare here the area of America, which is around here, North America, with Africa accurately here. And politically, this can be quite an important projection because things are in their right sizes. So this is Australia. You compare it to the UK, that size there, and the UK will just about fit down here in a small part of Western Australia. So it's called the interrupted good homolocene. It's interrupted because it's got gaps in it, but these gaps actually are where you can stitch this back together. If you printed it out and cut it out, you could stitch it back together into a globe shape. Okay, so that's the interrupted good homolocene. I'll let you experiment with putting that into the software and seeing what you get out of it. Now we're going to look at how you plot data onto maps with cartopy. So you need to know one extra thing here. So we've been using a map projection. We'll use the Mercator projection because this is fairly standard. And we're just going to cut it off at plus or minus 60 degrees because, well, there are very few Starbucks further north than that, although actually we've probably lost some in Finland. the vast majority of Starbucks are in the central, slightly northern band of the world, through America, Europe, UK, and China and Japan. Very few shown in Australia. I'm sure I remember one in Perth, which doesn't seem to be there. So you can get the Starbucks location data from Kaggle, and there's a couple of online sources that describe how to use it. The dataset comes with a location for each data point, which represents a Starbucks shop, store. We need to plot this on a map, and that means you need a projection for the map and a transform for the data. So when you need to map from a data set to a projection, you need to understand whether there's a data transform required between the data you stored and the data on the map. In this case, because the data is stored in latitude and longitude form, we can use plate carré, which is essentially don't do anything to the data. It'll get put on the map in the right place by the Mercator Projection. So you need these two things. You need a map projection to project the globe onto a map, and a data transform to take the data from whatever coordinate system it is into the world. And if you see plate carré, that just means there's no transform required because it's already latitude and longitude data. So this is the file for this. We need Pandas, we need matplotlib, we need the cartopy CRS, and we're going to use the cartopy feature set of functions, and we'll call those through cfeature. Here you'll see, as you just saw on the slide, we're setting up the map projection, we're setting up the data transform, then we're reading the locations using the standard Pandas read CSV file. We're adding a subplot with critically the map projection in it, and we're going to set the global view. We want to see the whole world. And we're going to add the coastline and the borders in the world in a tomato red color. So here's the scatter plot. We're going to choose X to be the Starbucks longitude and Y to be the Starbucks latitude. So these are directly from the data frame we just read in from the CSV file. Give it a color blue, set the size to be 1 and the alpha to be 0.5, just so that overlapping things can be seen. Sometimes there's quite a lot of stores, so they don't always it's not always obvious that you can see them. And you remember our data transform, the plate carré transform, we add that in here. So this is the data now, and we're saying how do we want to map the data? How do we want to project the data to the map? How do we want to transform it between data space and map space? And plate carré says don't really do anything to it because we've already got latitude and longitude. And then we'll show it. Okay, so let's run this. You will see from the plot that we've now got the Mercator projected world. All of the blue glyphs, the blue little tiny circles, are lat long points from the Starbucks dataset. If we zoom in on UK, you can start to see that there's quite a lot of detail in there, and that by zooming in you'll get to see more and more of it. We zoom in on London, where there's a lot of Starbucks. Now you start to see those. We've lost the map detail here, so we've lost the map context really, apart from the single line of longitude, which will be Greenwich, and there seems to be a Starbucks at Greenwich. So that's plotting data over map. Two things to remember: the projection choice for the map is important, but at least as important is the data transform. If you get that wrong, usually the data will end up somewhere you can't see it because it will be in a data space that's not viewable within the map range. Okay, so now on to something else. How can we use images as background in maps? This is quite useful when you've got really high quality imagery. And luckily NASA provides that from a number of its manned and unmanned space missions. This is the very famous Blue Marble dataset, which is a series of images of the Earth with no clouds on it. So you can see all of the continents and the seas at different times of the year. So this one I think is the December image, and every month of the year up until quite recently they've been producing different plots of the world. These are published, and it's important to know this, in plate carré. So they're not published in Mercator, so they wouldn't map directly onto a web image of a web map. But if we choose the right transform and coordinate systems for our cartopy Python, we'll be able to show it. You can get the images themselves from these two websites, and I'll just show you how to use them in a second. So one of the things I've done here is created a subfolder called BG. And within that, there's background images. And in this case, there's a set of Blue Marble images from a low resolution, medium, high, and ultra resolution. That's going from really quite low resolution up to about a 4K TV resolution. And that gives us a series of images. And then there's also a JSON file in there. So this is a JSON serialized file. JavaScript object notation, and it specifies particularly here, you'll see the images, and we need this later on so that the software can pull out which of these images it wants. So we give a name to each image, low, medium, high, and ultra for each of the appropriate files. So as well as Pandas, Matplotlib, and cartopy, we now need OS library to set up an environment variable called cartopy_user_backgrounds. And you'll see I give it the relative folder ./bg/, which is the folder I've just created with the NASA images I've downloaded. And we'll start off with a low resolution image just to show you what that looks like. And because it's downloaded, this should run locally if you're only showing the image, unlike some other mapping images which are downloaded as tiles dynamically. So here you go. So this resolution, you can't really see that the image is very low resolution. I think it was about 320 by something. But we'll zoom in and then you'll be able to see. We zoom in on the UK. We're using quite high resolution boundaries, but now you're starting to see the pixelation because the background map is such low resolution. There you go. So there's only maybe 40 pixels across the whole of the UK. But at this higher zoom out level, you still get quite a good impression of the whole world and the background map. So let's try it again and go for the highest resolution I've downloaded. You can get much higher resolutions from NASA, but this is the highest one I've downloaded for this example. So here's the blue marble image at high resolution with the high resolution coastlines on it. And we can zoom in on the UK and you'll see immediately, I hope, that there's a much better quality image there. There's a limit to how much I can zoom in. So if we try and look at the Isle of Wight, so here the boundary is a lot higher resolution than the background image. I mentioned I had downloaded another image, and if you change the name to base map, resolution ultra, I only downloaded one resolution for this, you can get this map instead of the standard blue marble map, and it's something that's used by a site called Earth Observatory as their background map. And we can zoom in on the UK, and you can see the quality there. If we zoom in again on the Isle of Wight, there you go. You've got quite a low resolution at the scale of the Isle of Wight, but going back to the whole world, we've got quite a lot of imagery there. So these are two different projections of the UK using local mapping, really. We're looking at UK cities in Plate Carré and in Mercator Projection. And you've seen the difference globally if you use these projections for a whole world. There's also a difference locally within a single country. And you can see the shape difference here. Which one looks more natural to you will probably depend on what you're used to looking at. But maps like this in Mercator Projection are fairly common. It's not that different to the OS's Ordnance Survey's projection. Okay, so is it possible to put data onto these maps? And the answer is yes. You can scatter plot on top of a cartopy map. And this is the TfL central line station data that we've seen. So these are all the stations on the central line, drawn in the central line yellow colour, on top of an OpenStreetMap background map. Coordinate reference system here will be taken from the map itself, and that will be Mercator for OpenStreetMap. And the data transform again is Plate Carré because TfL provides the locations in latitude and longitude format. So we're going to look at the code. This will be the last example in cartopy that we look at in this episode. So this is the Central London data. So we've got Pandas, Matplotlib, cartopy, the CRS, the C feature. And we need this new feature, which is image tiles, and we're going to import the OpenStreetMap image tiles. For this to work, it will need an internet link. So you have to go live on the internet to pull down the tiles, and every time you run it, it will do that. I believe there's a way to cache that, but this demo doesn't show that. I'm also using PIL to convert our image colors, and you've seen that before in the network episodes where we had to convert a hex color to RGB image color. First thing is set up the projections. The imagery is the OpenStreetMap, so that connects us to OpenStreetMap. And we take the map projection from the imagery itself. So the imagery coordinate reference system, CRS, comes from that OpenStreetMap data, and it will be Mercator. Then the data transform is Plate Carré. We read in the node table, which is the same node table we've seen before of the tube station locations. So we call the imagery, we give it a zoom level of 12. So there are different zoom levels. 10 to 16 tend to work. 10 is the most zoomed out version, and 16 is the most detailed and zoomed in version. So we convert the colours as before from the hex colour to the RGB colour. Then we do a scatter plot, remembering to set the transform to be the plate carré data transform so that the latitude and longitude are drawn in the correct places on the Mercator projected OSM OpenStreetMap map. We've set some other things as well, and particularly the Z order is 10, so that brings the stations to the front on top of the grids and the map. And their size is quite large, it's 160 units of space. Then we give it a title, and we give the title a little Y offset. So this helps us move the title above the map. Sometimes titles clash with the figures that they're above. Okay, we'll just run that so that we're plotting that over the map. So now you'll see that that's pulled the map down, quite low resolution at the zoom level we've asked for. But one of the benefits of that resolution is that the text is quite readable on this size of map. And the stations are being plotted as a scatter plot over that within the coordinate system. Okay, so that's the end of this episode. And thanks for watching as always.